Studies Section 12 Special Test Statistics Introduction. In this lecture, we shall be discussing some test statistics in details. These test statistics are useful tools in hypothesis testing. They are the t-test and the chi-square test. Some other test statistics will be examined in later chapters. Objectives. At the end of this lecture, you should be able to 1. Define and explain what a test of significance means. 2. Use the t-test and chi-square test as a tool for test of significance. Pretest. 1. The t-test is a useful test for difference of means. It is usually employed when the sample size is A. less than 30, B. greater than 30, C. less than 100, D. greater than 100. 2. The z-test is also a test of significance employed when the sample size is A. large, B. small, C. double, D. halved. 3. The test statistics for the goodness of fit is A. the correlation test, B. the chi-square test, C. the binomial test, D. the Poisson test. 4. The statistic calculated from the sample data which is used to validate the null hypothesis is called the A. good hypothesis, B. research hypothesis, C. text statistics, D. research statistic. 5. The test statistic that relies on frequency count for its categories than actual interval level measurement is A. t-test, B. z-test, C. p-test, D. chi-square test. Contents. Section 1. The t-test. A. It may be of interest to test whether the difference between the sample mean and the population mean is so significant that we cannot attribute it to chance factors or sampling variation. B. Likewise, we may have two different samples drawn from the same population, and our interest is to test if there is any significant difference between the means of the two samples. When we are confronted with problems like the above, the t-test is to be employed in carrying out the test. It operates by computing a critical value t, or t calculated, and comparing it with a table or t tabulated value at a specified degree of freedom and level of significance. T calculated is computed as follows. For the scenario A above, we use the formula T is equal to x bar minus mu over x over root n. Equation 12.1. For a small sample, when only the sample variance is known, or z is equal to mean minus mu over standard deviation over square root of n for a large sample, and when the population variance is known, where x bar is equal to sample, mu is equal to population mean, s is equal to sample standard deviation, sigma is equal to population standard deviation, n is equal to sample size. For scenario B above, we use the formula T is equal to x bar 1 minus x bar 2 over standard deviation square root of 1 over n1 plus 1 over N2, equation 12.3. For small samples, where standard deviation is equal to square root of N1 x1 squared plus N2 s2 squared over N1 plus N2 minus 2. And for a large sample, we use T is equal to S bar 1 minus X bar 2 over SED, where SED into bracket sigma D is equal to square root of sigma 1 squared over N1 plus sigma 2 squared over N2, equation 12.4. Symbols. S bar 1 is equal to means of sample 1. S2 is equal to mean of sample 2. N1 is equal to number of observation in sample 1. N2 is equal to number of observation in sample 2. Sigma is equal to pooled variance. S1 squared is equal to sample 1 variance. S2 squared is equal to sample 2 variance. SED sigma D in bracket is equal to standard error of mean difference. A sample is large when n is greater than 30, determining the degree of freedom. 1. For independent samples, df is equal to n1 plus n2 minus 2. 2. For one sample case, df is equal to n minus 1. Decision rule. If t calculated is greater than t tabulated, reject H0. If t calculated is less than t tabulated, accept H0. Let us now use an example to illustrate what we have discussed so far. Example 12.1. A Times survey reveals that the ages of JAMB candidates follow normal distribution, with mean 23 years and standard deviation 7 years. However, a randomly selected sample of 50 JAMB candidates shows that their average age is 25. Do we have enough evidence to conclude that the time survey was low? Solution. Let mu is equal to true population mean of JAMB's candidates. Step 1. Set up your hypothesis. H0 such that mu is equal to 23 years. H1 such that mu is not equal to 23 years. Step 2. Compute your Z statistics. Z is equal to X bar minus mu over standard deviation over square root of n is equal to 25 minus 23 over 7 over square root of 50 is equal to 2 over 7 times 7.07 is equal to 2.02. Step 3. Compare this value with the table value at 5%. Z 5% in bracket is equal to minus 1.96 to plus 1.96 in bracket. Since Z calculated falls outside this range, we reject H0 and conclude that the true population mean is something greater than 23 years. Thus, the value given by the Times survey is too low. Example 12.2. An arithmetic test is given to two sets of students. The first group consists of 30 students who attend evening classes after school hours, while the second group consists of 40 students who do not attend any extra lesson. Their mean and standard deviation are Group 1, N 30, M 20.5, SD 4. Group 2, N 40, M 16.2, SD 5. Is the difference in their average score due to chance? Solution. Step 1. Set up your hypothesis H0 such that x bar 1 is equal to s bar 2. Difference is due to chance. H1. S bar 1 is not equal to S bar 2. Difference is not due to chance. Step 2. Calculate SED. SED sigma D in bracket is equal to square root of standard deviation 1 squared over N1 plus standard deviation 2 squared over N2 is equal to square root of 4 squared over 30 plus 5 squared over 40 is equal to square root of 16 over 30 plus 25 over 40 is equal to 640 plus 750 over 120 square root is equal to square root of 1390 over 120 is equal to square root of 11.58 is equal to 3.4. Step 3. Compute T. T is equal to mean 1 minus mean 2 over SED is equal to 20.5 minus 16.2 over 3.4 is equal to 4.3 over 3.4 is equal to 1.26. Step 4. Degree of freedom. DF is equal to N1 plus N2 minus 2. DF is equal to 30 plus 40 minus 2 is equal to 68. Step 5. Check the table value of T. T tabulated 0.05, degree of freedom 68 in bracket is equal to 1.67. Step 6. Compare calculated T with tabulated T. Since T calculated is less than T tabulated, that is 1.26 is less than 1.67, we accept H0 and conclude that the difference between the two means is only due to chance. Section 2. The chi-square test. The chi-square test, denoted by x squared, is sometimes referred to as a goodness of fit test. It operates on categorical data which are recorded based on frequency count. For instance, if 1,200 children are randomly selected and asked what profession they would like to choose in their adulthood, we may get a data like the one below. Table 12.1. Number of children. Farmer 100, engineer 500, pilot 400, musician 200. Section 2. The chi-square test. The chi-square test, denoted by x squared, is sometimes referred to as a goodness of fit test. It operates on categorical data which are recorded based on frequency count. For instance, if 1,200 children are randomly selected and asked what profession they would like to choose in their adulthood, we may get a data like the one below. Table 12.1. Number of children. Farmer 100, engineer 500, pilot 400, musician 200. In table 12.1, the categories are the profession while the data are the number of children recorded. The task of the chi-square test, therefore, is to test whether the children are evenly distributed across the professions. Since we have 1,200 children and 4 professions, ordinarily we expect each profession to have 1/4 of 1,200 or 300 children, and the observed frequency are the ones in table 12.1. What chi-squared does is to compare the observed frequency with expected frequency. If a large difference exists between observed and expected, the chi-squared will have a large value and vice versa. It is computed by the formula x squared is equal to summation 0 minus e in bracket squared over e with k minus 1 in bracket degree of freedom. If there are more than one group in the contingency table, the degree of freedom will be df is equal to r minus 1 in bracket c minus 1 in bracket, where r is equal to number of rows, c is equal to number of columns. Example 12.3. 60 respondents were asked what their opinion is about convocation of sovereign national conference. The data was obtained. Support. Against. Total. Hausa, Igbo, Yoruba, total. 17, 8, 5, 30, 3, 12, 15, 30, 20, 20, 20, 60. Test the hypothesis that H0 ethnic affiliation and opinion on SNC are independent. H1 ethnic affiliation and opinion on SNC are dependent. Solution. The above given figures are called the observed frequencies. Step 1. Calculate the expected frequencies thus. Support. Hausa. 20 times 30 over 60 is equal to 10. Igbo. 20 times 30 over 60 is equal to 10. Yoruba. 20 times 30 over 60 is equal to 10. Total is 30. Against. Hausa. 20 times 30 over 60 is equal to 10. 20 times 30 over 60 is equal to 10 as Igbo. Yoruba. 20 times 30 over 60 is equal to 10. Total 30. Total 20, 20, 10, 60. Step 2. Tabulate the frequency columns as follows for easy computation. 0, 17, 8, 5, 3, 12, 15. E, 10, 10, 10, 10, 10, 10. O minus E, 7 minus 2 minus 5 minus 7, 2, 5. O minus E in bracket squared. 49, 4, 25, 49, 4, 25. O minus E in bracket squared over E. 4.9, 0.4, 2.5, 4.9, 0.4, 2.5 is equal to 15.6. Step 3. Compute x squared. X squared is equal to summation 0 minus E in bracket squared over E is equal to 15.6. See the procedure in step 2 above. Step 4. Compare calculated x squared with tabulated s squared. Degree of freedom is equal to 2 minus 1 in bracket, 3 minus 1 in bracket is equal to 2. Since we have 2 rows and 3 columns, x squared tabulated, 5% command, degree of freedom 2 in bracket is equal to 5.99. Step 5. Decision making. Since x squared calculates is greater than s squared tabulated, that is 15.6, is greater than 5.99, we reject the H0 and conclude that ethnic affiliation and opinion on the convocation of sovereign national conference are dependent, that is, whether a respondent is in support or against SNC depends on his ethnic affiliation. Summary. The t-test is a useful test statistic usually employed when testing whether difference between two means is significant or due. The chi-square test is a goodness of fit test which operates on categorical data recorded based on frequency counts. This is the end of study section 12. Thanks for listening.